Hello, geometry students. In this lesson, we're continuing with trig. Specifically, we're going to be talking about what's called the inverse, the trig inverse. This sounds a lot more intimidating than it is, but really all it is you use the inverse when you are looking for the measure of an angle. If you write trig functions, remember it's Oscar had a heap of apples, or SOHCAHTOA. If you write sine, you have to have an angle. There's always got to be an angle there. So cosine of an angle, it's not correct to just say cosine. It's tangent of an angle. You must always have the angle. So the sine of this angle, the cosine of this angle, the tangent of this angle is equal to opposite over adjacent. Well, what if you don't know the angle? If you know both the sides and you're trying to find the angle, you're going to use what's called the inverse. You can see it's raised to the -1. It's not quite the same thing as the typical -1. It's also sometimes called the arc cosine, the arc sine, and the arc tangent. Those terms seem a little old-fashioned to me, but I'm old-fashioned. How do you do this on a calculator? There will always be an inverse button, and it's usually connected to the sign. If you look at this, if you say sine of a number, it's going to give you the sine of that angle. So the sine of 37 degrees is going to be 0.6. But if you want to find the angle, if you know the sine itself, then you can do the second inverse, and it will actually tell you the angle itself, and there it is. If you're trying to find the angle, you will use the inverse. If you're trying to find an angle measure, you will always use the inverse. So with that in mind, it says it right there. Trig inverses, you always use it if you're trying to find an angle. This looks kind of complicated, but really all it is it's saying I've got theta, theta, theta. What's the inverse of sine? It's equal to theta. What's the inverse of cosine? It's equal to the angle measure. So with that in mind, number one says use the inverse trig function to determine the degree measure of the angle shown. I'm looking for this angle. It looks like it could be, I don't know, maybe 37 degrees or maybe 40 degrees. So what I need to do is I need to figure out what I know. I'm standing here. This is my hypotenuse. This is my opposite, because it's over, and this is adjacent because it's attached. You can use any trig function you want. Remember, Oscar had a heap of apples. Sine, cosine, tangent. So I'm just going to write down, I'm going to use sine. Here's the formula for sine. Sine of theta is equal to opposite over hypotenuse. But I want the angle measure, so I'm going to sort of reverse this. The sine inverse of opposite over hypotenuse is equal to the angle measure. You basically just switch positions for those. So I'm trying to find an inverse, I'm trying to find an angle. So sine inverse of opposite over adjacent is going to equal what I'm looking for. All right, well, if you're standing here, the opposite is 39, the hypotenuse is 65, and there's your answer. Plug that into your calculator using the second inverse button. It depends on the calculator you're using, obviously. And you can go ahead and type in 39 divided by 65, and I get 36.8 degrees. I look over here and I say, yeah, that looks like it could be a 37-degree angle. I have found the angle measure using the inverse sine function. Incidentally, I could also have used the inverse cosine. Maybe I'll do that on the next one. Use the inverse trig function to determine the measure of the angle shown. Maybe I'll have to. So if you're standing here, this looks like a very thin angle to me. I'm thinking maybe 20 degrees. If you're standing here, your hypotenuse, the hypotenuse never changes. It's always across from the right angle. I don't know it, so I can't use it. So if you think about your trig functions, Oscar had a heap of apples. The only one that doesn't use the tangent, or the only one that doesn't use the hypotenuse, is the tangent. I'm going to have to use tangent on this one. So to finish it, if you're standing here, this is your opposite because it's over, and this is your adjacent because it's attached. You don't have to go anywhere to get to it. So I'm going to use tangent. Tangent of theta is equal to opposite over adjacent. But I don't want the tangent, I want theta. That's equal to the inverse tangent You can see that all I do is just switch those. The theta now becomes by itself, and the opposite over adjacent. The ratio itself, which is that 4-digit number, goes into the formula. Now, I don't know the 4-digit number. You can do it if you want to, but I'm just going to let the calculator do all the work at once. Opposite is 6 over 20. That's my answer. Just put that in your calculator, and it will tell you the answer. The second inverse tangent of 6 divided by 20. Now, my answer is 16.7, but I always like to say check to make sure your answer makes sense. This is an angle measure. It looked pretty thin. I thought it could be 20, so I'm pretty content that it could be 16.7. Actually, I think I would just round that to 17 degrees because the decimal seems kind of needlessly specific. So, yes, that's a 17-degree angle. If you're trying to find the angle, you use the inverse. How about a real problem? An airplane is taking off. When the plane is 400 meters from the liftoff point, the plane is 300 meters high. I'm looking for the angle of elevation. I'm looking for the angle. If you're looking for the angle, you're going to use an inverse. Angle gives you the inverse. So I need to figure out these sides. Hypotenuse. I don't know it, can't use it. Hopefully you remember that the only one that doesn't use said it again. The only one that doesn't use the hypotenuse is the tangent. So I am going to use the tangent in this relationship, but I don't want tangent. I want inverse tangent because theta is equal to inverse tangent of opposite over adjacent. All right, well, if you're standing here, this one is adjacent because it's attached, and this one is the opposite. So let's figure it out. Theta that I'm looking for, they actually called it x, is equal to inverse tangent of opposite over adjacent. Put that in your calculator and you'll have that angle measure, which to me, looking at the picture, looks like it's about, 40 degrees. Maybe it's 37. Inverse tangent of 300 divided by 400. There it is again. It's actually 37 degrees. And of course, I knew that because this is a 3-4-5 triangle, and I happen to know the angle measure for a 3-4-5 triangle. Look at the next one. A portable metal ramp is 30 meters long. This is the 30 meters long. I'm looking at this from the side. What I've got is a ramp that's going up to, say, a loading dock. And this length is 30 meters. That's a long ramp. It needs to be placed to reach an opening that is 9 meters off the ground. There's no way I would ever walk up that ramp. OSHA regulations restrict the ramp angles to no more than 15 degrees. This cannot be more than 15 degrees. I want to see if I'm correct. So I'm trying to find the measure of this angle. I need to make sure it's less than 15 degrees. If you're standing there, this is the hypotenuse, and this is opposite. Oscar had a heap of apples. Don't want the adjacent, so it's got to be the cosine. The sine. So, sine, but I'm looking for an angle, so it's the inverse of the sine. The sine is equal to opposite over hypotenuse. So to find the measure of the angle, you say inverse sine of opposite over hypotenuse. That's the answer. Put that in your calculator. Inverse sine 9 divided by 30. And you get 17.4 degrees. This is in excess of 15 degrees. That's the answer, but you got an OSHA violation there if you have that. One last thing, and that is I'm just going to go straight forward to this. This is probably something I should have done first. Here's my 4-digit number. This is the ratio. This is, for cosine, this is equal to the adjacent over the hypotenuse. Somebody already did that calculation for me. For the sine, this is the opposite over the hypotenuse. Somebody already did that calculation for me. This is the opposite over the adjacent. Somebody went ahead and put that into the calculator and found it for me. So now I want to find the measure of theta. Well, theta is equal to the inverse cosine of this ratio. On the other ones, I was putting adjacent over hypotenuse. I'm going to go ahead and put in the actual ratio. And again, notice that I'm pretty much just reversing these positions to find the measure of the angle. So, inverse cosine of my ratio, which somebody already did the calculation for me, this is 45 degrees. How about this one? Inverse sine of opposite over hypotenuse. But I know that opposite over hypotenuse has already been done in the calculator to give me a 4-digit number. So, inverse sine of the ratio. And this is a 60-degree angle. And one more. The inverse tangent of opposite over adjacent, but somebody already put that in the calculator and found out that opposite over adjacent is really 5774. So inverse tangent of that ratio is 30 degrees. And that's that.